Hello, my dear mechanical and civil champions. How are you all? What's up? ऐसे हैं सब लोग? This is Chandrashekhar welcoming you all to the India's largest, the best, and your favorite live learning platform, that is BYJU'S. So I hope everyone is safe and sound. As you can see over the screen, today we will be talking about the another technique in project management, that is PERT. So guys, those who are watching me live, please respond through the comment section if I'm audible and visible to you all perfectly, so that we can start the session on time. The topic is very important. There are two techniques in project management. One is CPM method, which we have already talked about, and we have also talked about crashing of an activity in critical path method. Those who have missed the previous sessions, please watch the recording. They will improve your understanding about the project management. So today is all about the PERT analysis or the project management by using the PERT technique. Hi Amon, good evening, welcome to the session. Please do let me know what is your understanding about PERT. Meanwhile, please do let me know what do you know about PERT? Where do we use? How do we use? What is the full form of PERT? This is my introduction. Most of the students already know me. I am a mechanical engineering graduate from IIT Delhi and also cleared engineering services examination, worked in SAIL, and from last 10 years I am completely into teaching, guiding the students who are preparing for various competitive examination, and I am quite comfortable in these many subjects of mechanical and civil engineering. So this PERT is part of project management, which is common for mechanical as well as civil aspirants. In civil, it is part of construction planning and management, and in mechanical, it is part of industrial engineering. Please guys, do let me know through the comment section. Those who are watching me live, please mark your presence by writing in the comment section. This is my mail ID. You can always contact me through my official mail ID, and I would recommend you guys to be part of my Telegram group, Mechanical by Chandrashekhar. Yes, I'm on. Very nice. And this is the link of my Telegram group. Once you join me on the Telegram, you will be getting the exam notifications. You will be getting the PDF of all my classes which I take from time to time, and daily important questions and doubt resolution will also be there. So you will be getting the benefit if you become part of my Telegram group, that is Mechanical by Chandrashekhar. You can also join our paid courses. BYJU'S is running paid courses and free sessions. Once you join our paid course, that is more organized, more structured, you will be having better and better chances of scoring the best possible rank in GATE examination. We have proved our quality by producing all India single digit rank in previous years. And if you do not want to join us through the paid courses, you can attend all the free sessions. We keep on providing you the free content. Those who are serious aspirants for GATE or ESE examination, so for that you need to like, share and subscribe our BYJU'S YouTube channel, so that you will be getting all the notifications. That is the basic notice or basic information about our courses. So those who have missed our previous session, this is my complete class schedule for this series, that is project management. So we started on 15th. So if you have missed those classes, I have mentioned the links for those classes also. The first class was all about the network diagram, and then we talked about the critical path method, then the crashing of an activity, and today we will be going to discuss about PERT analysis. All right, shall we start? And do not forget to join me tomorrow at the same time, 7 p.m. for the quiz. We will be having the quiz to make you understand about your knowledge about CPM as well as PERT. So do not forget to join me with your full preparation tomorrow. Shall we start? Are you all ready? Please make some noise. Those who are watching me live, those who are ready to explore the beauty of PERT, please make some noise. Hi Manikanta, good evening, welcome to the session. Good to see you. How are you? I hope your preparation must be going in the right direction with your full enthusiasm and full positivity. Shall we start playing? As usual, there is a question in front of you. So please do let me know your opinion, your answer about the question given on the screen. What do you know about PERT? In PERT analysis, the distribution of activity time is assumed to be. Which distribution is assumed in PERT analysis for the activity time duration? What is your answer? Quickly do let me know. Everyone, I want everyone to respond. Do not be mute spectators, because once you will be mute spectator, it means you are not open to learn. And if you are not open to learn, then nobody can teach you. So to have better understanding, you should always communicate, you should always be attentive, you should always raise your concern, raise your doubts, you should always share your knowledge. That is how it improves more and more. Nobody has responded me yet. Then only we will proceed further. And if anybody is having anything to ask, do let me know through the comment section. The activity time estimates. No, Hassan. That is the confusing part in PERT analysis. That is the point where most of the students are getting the confusion. There are two time estimates. One is activity time, that assume the beta distribution, whereas the another one is project completion time. Yes, Kumar, very nice. Activity time estimate. So you need to read the question very carefully, whether it is about the activity time estimates which follow beta distribution, and the project completion time follows the normal distribution. You must be knowing about the PERT, program evaluation and review technique, which is event oriented technique. It talks about it focuses on start or finishing of an activity. Event oriented. The PERT is used when the activity time are more uncertain. There are more uncertainty. So that is why it is probabilistic approach. More uncertainty is there. So we use probability. It involves the probability. That the approach is known as probabilistic approach. Mainly used in research and development projects or the new projects. Mainly PERT is used in research and development kind of projects which are very new. For the existing project, we generally use CPM method, and for new projects, we generally use the PERT method. So because activity time estimates follow the beta distribution, what exactly is the beta distribution? It is nothing but the special case of normal distribution. Normal distribution. Special case of normal distribution where the mean shifts either left or right. Left or right. The beta distribution is having two intercepts on x-axis. There are two intercepts on x-axis. The beta distribution is also called as unimodal. What is unimodal? It means shape of distribution won't change. The shape of the distribution won't change by changing any parameter. That is called as beta distribution, changing any parameter. These are the properties of beta distribution. All right. So if I show you the beta distribution for an activity time estimates, this is how beta distribution will look like. It will look like this. There are two intercepts on x-axis. On x-axis, it is the activity time estimates. Activity time estimate. Activity time estimate. So the first intercept is TO, that is optimistic time. The second intercept is pessimistic time. And the mean is, what is the mean? That is TM, that is the most likely time. So this distance is 3 sigma plus 3 sigma, and this distance is minus 3. That is how beta distribution will look like. That is how the beta distribution looks like. So there are for an activity, because there is high uncertainty in activity time. In CPM, there is very less uncertainty because they are old projects. But here, because of more uncertainty, we define 3 time estimates for an activity. One is optimistic, most likely, and the pessimistic time. TO is, we can say, TO is less than TM is less than T. What are the definition of these time estimates? What is, so first of all, we need to draw the network diagram using the precedence relationship, and then we need to find out the expected activity time duration. किसके लिए बेस्ट बुक बता दें? दीक्षित, किसके लिए चाहिए आपको बेस्ट बुक? इंडस्ट्रियल इंजीनियरिंग के लिए एमडी 8 ताहा ताहा Okay, Praveen. Look, first of all, you need to draw the network diagram using all the precedence relationship which we have discussed, right? Then we need to find out the expected activity time duration by using these 3 time estimates. What is optimistic time? When the activity is not facing any hurdle, the time estimate is optimistic time. For an example, you are going from your house to your college. That is the activity. You are going from your house to your college. So if I ask you what is the optimistic time to reach from your house to your college, which means when there is no traffic, when there is no red light, when there is no kind of any hurdle during your journey, when the traffic is very smooth, you are not supposed to apply the brake to your vehicle, then you will reach your destination in the minimum possible time. You will reach your destination in minimum possible time. That is called as optimistic time. What is the pessimistic time? Pessimistic time is the time taken by an activity when the activity is facing all the hurdles possible, when everything goes wrong, when you are getting the traffic also, when there is an accident on the road, when red light is also there, and you are caught by the traffic police also. If all the type of hurdles are there in the activity, then you will have the maximum time to complete the particular activity. That is called as pessimistic time. And most likely time, that is the time taken by an activity when the activity is facing some hurdles, only few hurdles, the normal routine. Normally you will not, if your luck is very good, then you will reach your destination in optimistic time, and if your luck is very bad, then you will reach your destination in pessimistic time. But most likely time is the time taken by an activity when few things goes wrong but few things goes well also. So that is why you will reach your destination most of the time in most likely time. Most of the time you will complete a particular activity in most likely time. That is why more weightage is given to that particular time duration or that time in calculating the expected time. This is how you can calculate the expected activity time duration TE, which is calculated by TO plus 4 TM, 4 is the weightage given to TM, plus TP divided by 6. That is the expected activity. Why we are using the word expected? Because there is high uncertainty. That is why we are calculating the expected activity time duration. All right. In CPM, the time durations are already mentioned. No need to calculate the expected activity time duration, but in PERT, you may find the 3 time estimates and you need to find out the activity time duration or expected activity time duration using this. And then you can find out the critical path using this expected time duration. You need to find out the critical path. And from the critical path, you will be able to find out the critical activities and the project completion time. For an activity, standard deviation is calculated by this formula. How we are getting this formula? Sigma for an activity is calculated by TP minus TO by 6. As we know, TO is less than TM is less than TP. TP is the maximum time duration. Pessimistic time, when all the hurdles are there, TO is the minimum time duration taken by an activity when everything goes well. So we can say TP is equal to TM plus 3 sigma, isn't it? Sigma for an activity, and TO is equal to TM minus 3 sigma. If you see the previous, TO is equal to TM minus 3 sigma, TP is equal to TM plus 3 sigma. If you subtract these two, you subtract, then we can say TP minus TO is equal to 6 sigma, or sigma for an activity is calculated by TP minus TO by 6. That is how we can find out the standard deviation for any activity. And after standard deviation, we can find out the variance of an activity, that is sigma square. Variance of an activity is sigma square, or we can write it as, that is TP minus TO divided by 6 whole square. That is the variance of an activity. Variance of an activity represents the measure of uncertainty. It gives us the measure of uncertainty of an activity. Standard deviation or variance is nothing but the measure of uncertainty for an activity. More is the variance an activity has, it means more will be the uncertainty in completion of that particular activity. So these are the things you need to calculate beforehand. So this is all about beta distribution, that is activity time duration curve. Now the project follows normal distribution curve. The project completion time follows the normal distribution curve. How the normal distribution curve will look like? This is how the normal distribution curve will look like. This is minus infinity, this plus infinity. The curve will be looking like this. It is not having like this. This is x bar and this is x, or we can, because it is parallel to x-axis, the curve becomes parallel to x-axis, we can have up to this portion of the curve, that is plus minus 3 sigma for the project, and this point represents plus 3 sigma for the. This is fx. This curve represents the probability distribution curve. Probability distribution or probability distribution, or it can be called as probability density curve. Probability density curve. Probability density curve. Okay. There is a parameter defined that is called as Z is equal to x minus x bar upon sigma for the project. P for project. What is Z here? In this expression, Z is known as standard normal variant. Standard normal variant, or we can also call it as, it is the total slack. It represents the total slack. Slack is float. Slack is used in PERT, and the same parameter, the same concept is used in CPM with the name float, total float. In CPM, we use the word float, extra time available with an activity. That represents the total slack on critical activities. On critical activities. Critical activity. Total slack on critical activity. Z is equal to x minus x bar upon sigma for the. This is how the normal distribution looks like. It is probability density functions. So if x is equal to x bar, if the value of x is equal to x bar, we can say z is equal to 0. This is z is equal to 0. This point represents x, maximum value of x. This point represents minimum value of x. Or we can say z is equal to plus 3 here. Z is equal to plus 3, or z is equal to minus 3. Now, what is x bar here? If we talk about, this is very, very important formula in normal distribution. What is x bar? X bar in this expression, or in this, represents the expected project completion time, which we can calculate by using the critical path. It is the expected project completion time. X bar is the expected project completion time, can be obtained from the network diagram critical path. Can be obtained from critical path using network diagram. All right. And what is x? X is the time in which we want our project to be getting completed. We want the project getting completed, to get completed. X bar is the expected project completion time, which can be obtained. The first step is to draw the network diagram. The second step is to find out the expected activity time estimates using the optimistic, pessimistic, and most likely time. Then put those values on the network diagram and find out the critical path. The longest path of the project will be critical path, and the sum of time taken by the critical activities will represent the project completion time. So x bar is that project completion time, and x is the time by which we want the project to get completed. And sigma for the project is under root of sigma variance of critical activity. Variance of critical activity. Variance is square of sigma. Variance is square of standard deviation. So this is how we can find out sigma for the project. Sigma for the project is also called as standard deviation of the project. There is a difference between standard deviation of activity and standard deviation of the project. It is representing the uncertainty of the project completion. This sigma represents uncertainty of project completion, whereas this sigma of an activity represents uncertainty in activity completion. Getting it? Standard deviation of the project, or critical activities, or critical path, or we can call it as critical activity. Path or critical activity. Standard deviation of the project is same as standard deviation of the project is same as the standard deviation of the critical path or the critical activity. Or we can also call it as Sigma for the project represents measure of uncertainty of project completion. Measure of uncertainty of project completion. Is this clear? Now we find out, after this, we find out PZ. PZ. That is integration of minus infinity to x fx dx. That is called as probability of completion of the project. This is area under the normal distribution curve. It is nothing but or area under normal distribution curve up to x. Up to x. It is also called as cumulative probability. Cumulative probability. So what is PZ? PZ is the probability of completion. Probability of completion of the project in time duration x. In time x. Probability of completion of the project in time x. So this is how we find out the probability of completion of the project in time x. Let us take a couple of examples. If we take an example, if I say if x is equal to x bar, what does that mean? If x is equal to x bar, it means we need to find out, we can say what is the value of z. What is the value of z? If x is equal to x bar, z is equal to 0. If I draw the normal distribution curve, this represents z is equal to 0 or x is equal to x bar. So area, this is minus infinity, and up to x, the area under the curve. What will be the area under the curve? This will be the area under the curve. So what is the value of PZ? Z is equal to 0 implies total slack on critical activities will be 0. That is the total slack on critical activity. Slack on critical activity. If x is equal to x bar, it means if we want to find out the probability of completion of the project in x bar time, that is the expected time. So that is the PZ will be, what is the value of PZ? How much is PZ? Can you just let me know? What will be the value of PZ? PZ is the area under the curve. Area under the normal distribution curve up to x. And x is equal to x bar means this point. So are you getting 50% or not? That means it is the probability of project completion, or we can say it is the probability of %50 is the probability of project completion in expected time, in expected project completion time. Expected project completion. Probability of project completion in expected project completion time. that is 50%. So if we want to find out the possibility of the project getting completed in the expected project completion time, that is 50%. Getting it? Now if we want the possibility of the project getting completed in more time than the expected time, if x is greater than x bar, then we can say z will be positive. Z is positive, which means these z is equal to total slack on z is greater than 0, means total slack on critical activities. Try to understand, this is very important. If we want the possibility of the project getting completed in the expected time, which we have calculated by using the network diagram or the critical path method. So if we want to check the possibility of the project getting completed in that particular time, then it is 50%. And in that particular situation, the slack on all the critical activities will be 0. There is no extra time available with any of the critical activities. Are you getting it? Z will be equal to 0. That is the normal variant. Now, if we want to find out the probability or the possibility of the project getting completed in more time than the expected time, do you agree that the possibility will be more? If a particular project is getting completed in 10 days, but if we want to find out the possibility of the project getting completed in 10 days is 50%. But if we want to find out the possibility of the project getting completed in 12 days, then it will be more than 50%. If the time duration is more, then the chances of getting the project completion is more. So if x is greater than x bar, x is the time in which we want the project getting completed, and x bar is the expected project completion time. So if this is the situation, that will be positive. It means the critical activities are also having some slack, the positive slack. That is the total slack on the critical activities. In CPM method, the total float on critical activities is always 0, but here the total slack on the critical activities will also be there if we want the project getting completed in more time than the expected time. In that case, if we talk about PZ, this is x bar and this is, let us say, x. If we talk about this, it is the area under the curve, projected area under the curve on normal axis. So this area will represent PZ, and you can say it is greater than 50%. The chances are more than 50%. The chances of getting the project completion is more than 50%. So if we want to, as we know, x is equal to x bar, x is equal to x bar plus z plus z into sigma for the project. If we want x to be x maximum, if we want x maximum, then we can say x bar plus z maximum into sigma for the project. And what is the maximum value of z? Z maximum is plus 3 sigma. Z maximum is equal to plus 3. So we can say the maximum time by which a project can get completed is x bar plus 3 sigma for that. That is the maximum time in which the project getting completed. Z maximum is equal to 3 plus 3. Similarly, if we want the project getting completed in less time, then we can say Z will be negative. That is the total slack on critical activities. It means if we want the project getting completed in 8 days, 10 days is the expected project completion time. But if we want the project getting completed in 8 days, then the critical activities will be having negative slack. It means it is the negative extra time available, means there is no extra time available, but we need to crash the activities, critical activities, if we want the project getting completed in less time duration then the expected time. Z will be negative, total slack on critical activities will be negative. Will be negative. And if we want to find out PZ, then the chances will be less than 50%. The chances rho is how the curve will look like, normal distribution curve. Now, if x is less than x bar, then this is the area under the curve, which is less than 50%. The chances are less than 50%. We can say if z is plus 1, so for x is equal to x bar plus 3 or into z, x bar plus z into sigma for the project. If we want x minimum, that is equal to x bar minus 3 sigma for the project. That is the minimum time in which activity a project get finished. Z minimum is minus 3. So if we want the project getting completed in minimum time, that is minus 3, the chances are only 0.13%. This is for normal distribution curve. These are the probability distribution for normal curve. These are the standard values. So if we want the project getting completed in X minimum, then the chances are only 0.13%. It is not even 13%. Similarly, if we want the project getting completed in maximum time, that is Z is maximum, that is plus 3, then the chances of completing the project in maximum time is almost 100%. If we want the Z to be plus 2, the chances are 97.72, and for minus 2, it is 2. For plus 1, it is 84.13% probability, and for minus 1, it is 15.1. 84 plus 13 plus 15.87 is 100. The addition of these two will be 100. Similarly, the addition of these, that is the addition of. So that is how we can find out. The important point here is you can see the total slack on the critical activities can be 0 also. The total slack on the critical activities can be positive also. The total slack on the critical activities can be negative also. So the final point here is on the critical activities, the total slack is minimum. The total slack on critical activities. So we will discuss one question now. Critical activities can be negative, can be positive, or can be greater than. We can say in PERT, critical activities have minimum total slack. Have minimum total. In PERT, critical activities are having minimum total slack. Is this clear to everyone? Praveen, are you talking about the beta distribution or normal distribution? Probability is not negative. Probability is not negative. We will talk about that. Let us discuss this question. Let us discuss this question, how to find out X bar and all. The figure, this is the figure given, illustrates a PERT network. Describe the network diagram is already given. The precedence relationship among different activities. The optimistic time, most likely time, and pessimistic times are given in the table. These are the values for activity 1 to 2, optimistic, most likely, and pessimistic. This is how they are in increasing order. TO is less than TM is less than. For all the activities, the time estimates are given. Now the question says we need to find out the length of the critical path. The length of the critical path is expected project duration. Project completion time. Project completion. We need to find out the expected project completion time, and the standard deviation of the critical path, or we can call it as standard deviation of the project, sigma for the project. These are the two things we need to find out. Now, first of all, what we need to do is we need to find out the expected activity time. Expected activity time by using this formula TO plus 4 TM plus TP by 6. Can you do the calculation to find out the expected activity time duration? 9 into 4 plus 7 plus 11 divided by 6. That will give the expected time for activity 1 to 2. If we do the calculation, it will be 7 plus 4 into 9 plus 11 divided by 6, 36, 37, 40, 50, 60 by 6. Is it 50 by 6? 54 na? 54 divided by 6, it will be 54 divided by 6, that is 9. It will be 9. It will be 9. Similarly, if I do the calculation for each and every activity, then for activity 2 it will be 7, then 7, then 10, then 9, then 10, then 6, 8, 5. These are the expected activity time duration using this formula. Now using these values, we can easily identify the critical path. 1 to 2 is taking 9 hours to get completed. 1 to 3 is taking 7 hours to get completed. 1 to 4 is taking 7 hours to get completed. 2 to 5 is taking 10 hours. 2 to 5 taking 10 hours. Then 3 to 5 is taking 9 hours, is 9. And 3 to 7 is 10 hours. And 4 to 6 is 6 hours. And 5 to 7 is 8. And 6 to 7 is 5. Can you find out the critical path? Can you find out the critical path for this? What will be the critical path? Can you identify the critical path? The longest path of the project. Here, the expected time duration for activities are mentioned. So what is the longest path? Is it 1, 2, 5 and 7? Critical path will be 1, 2, 5 and 7. Isn't it? 1, 2, 5, 7 will be the critical path. 1, 2, 5, 7. And the time duration will be 9 plus 10 plus 8. 27 hours. The answer will be, so the answer to the first part will be 27 hours will be the length of the critical path. Now we need to find out the standard deviation of the project. Sigma for the project is equal to under root of summation of variance on critical activity. We need to find out the variance of critical activities, and variance of any activity is equal to sigma square, or we can say TP minus TO by 6. That will give the variance of any activity. So we are interested only in critical activities, that is 1 to 2, then 2 to 5, then 5 to 7. We are interested only the 3 activities. So what is sigma for the critical activity 1 to 2? That is TP minus TO divided by 6. 11 minus 7 divided by 6. 11 minus 7, 4 by 6. So 2 by 3. Can we write it as 2 by 3? 2 by 3. We do not require the standard deviation for these activities. Now for 2 to 5, again 12 minus 8. That is 4 divided by 6. That is again 2 by 3. We do not require for these. We do not require for these. And for 5 to 7, it will be 11 minus 5. That is 6 divided by 6. That is 1. We do not require this. And sigma square will be the Sigma square will be the variance. So it will be 4 by 9, will be 4 by 9, be 1. If you add these all the variances, so sigma for the project or sigma for the critical path is under root of 4 by 9 plus 4 by 9 plus 1. Isn't it? Under root of 4 by 9 plus 4 by 9 plus 1. We can say what is that? Just a second. Are you able to see it? So it will be under root, it will be under root of 17 by 9, that is equal to 1.3. The project for the project, it is 1.37. That will be the answer. Isn't it? So that is all about PERT method. So this is the homework. Please try to solve this question. This is the precedence relationship. You need to draw the network diagram on your own, and then you need to find out the critical path. This is expected time is already given. You don't have to use the formula optimistic time, pessimistic time, etc. And the question says the expected project completion time is what, and the standard deviation of the critical path also you need to find it out. All right, that is all from my side for the day. Tomorrow at 7 p.m. we will be meeting again, and we will discuss, we will have the quiz for the CPM and PERT analysis. All right, so that is all from my side. Enjoy, take care, have a good day, and stay safe, stay motivated. You can join me on the Telegram. The link is Mechanical by Chandrashekhar, and link is also mentioned. All right, so with this motivational saying, never stop learning. Learning is a continuous process. You should keep on learning with your positive mindset. You should always be open for learning. Then only you will feel the improvement, continuous improvement. All right, with this note, let me take your leave. See you tomorrow. Thank you guys. Thank you very much.